For this next example, I had students write a program in C called llcycle. This program contains a function that detects if a linked list has a cycle or not. The way how I decided to grade their solution was to write a small wrapper C program around the function that they had so that I could verify that this function works as intended. This file is just creating these linked lists and then passing it into the function that the students created. And then I'm checking to see if the result matches what I expect. So you can see here, this not is saying that this program should return a value of false, but it is correct if it is false, so I'm returning true. You could easily make this much more readable. This was just a really lazy approach. And then you can see here, I'm just passing along the is correct and then checking the results of each of these different test cases. The way how I return this result back to my Python autograder is by returning an exit code of 0 if the student's code passed or 1 if it failed. This is not always the best way of doing it because you don't always give that much information to the students, but this is a very, very simple way of passing results back to the Python autograder. A benefit of doing this small wrapper is it allows me to do all the heavy lifting of compilation and verifying that files exist in Python, which is much easier to write, in my opinion, than it is to do it all in like C or some other scripting languages. So you can see here, first, I'm grabbing the student's file llcycle, which contains the function that they had to write. And then I have the file of this test that I had wrote that will wrap around the student's function. My first step is to do a system call. There's multiple ways of doing this. I was just lazy in this way. I just called system so that I could call GCC, which is a C compiler, to compile both the student's code and then my test code, and then link all of them together to create a binary output called test LLC. The first thing I do is I check to see if the result of what this command is 0. If it is 0, that means that I successfully compiled the code. If it is not 0, that means that something failed in the compilation, and I want the students to know that they did not pass it because there was some compilation issue. I could return the results of what this compilation is to students, though I don't necessarily always want the students to see the inner workings of the autograder, so I tend to give more generic error messages like this, though I try to be as specific as I can so that it helps the students without them having to come to us. So this autograder just does a subprocess.call, which is basically, I want Python to execute this program, which is test LLC, and then return back the exit code of what this program returns with. So you can see here, I'm returning this variable is correct, which will just be 0 if the program passed, as in llcycles correctly detected all the test cases that I had, or it will return something non-zero. In this case, if you look back at my test code, it will return 1 if there was something in here that failed. And so we can see here it will pass or fail based off that. Once again, this doesn't give the most visibility to students about why it doesn't pass, but you could always do something like have this return some standard out that Python would then read and interpret and give back to students about which parts of this they might have failed.